Hello everyone, my name is Ashish and welcome to the Xadmin channel. So today we are going to discuss about a linked list topic in our data structure series. So in my last lecture, we have discussed about a queue, and there we have seen that what is queue and how the queue works. And also we have implemented a custom queue in a Java language. And in that previous lecture, we have discussed about a stack, and also we have seen how we can write our custom implementation program for a stack in a help of Java language. So guys, if you have not seen that lecture, then I will suggest you to watch that lecture of a data structure in the topic of queue and a stack. So today we will start with a linked list. And so the agenda of this like session of a linked list, in this we are going to discuss the topics like what is linked list and why we can use a linked list, and why and also we are going to compare the linked list with the array, and why means how the linked list is better than array. And also we are going to see the advantages of linked list, the drawbacks of linked list, and also we are going to discuss the type of linked list present. And then we are going to write a program or a custom implementation of a singly linked list. And there inside that program we are going to do write a custom methods. The first, we are going to implement a method in which we are going to see how we can add an element in the starting of a linked list. And then we are going to write a method in which we are going to see how we can delete any element from the linked list. And also we are going to write a method to add an element in the end. And also we are going to display all the elements from a linked list. So these are the method implementation which we are going to see. So the next topic which we are going to see, we are going to write a program in a Java language for a doubly linked list. And in that program also we will write some like methods for adding an element in the starting, for deleting an element, and also for adding an element in the end. And also we are going to discuss a singly linked list and doubly linked list difference between. And also we are going to write a program for a circular linked list. So these are the topics which we are going to discuss in this like session of a linked list. And I'm going to divide this like session of a linked list into three parts. So guys, let's start our session without any like further delay. So first thing we will discuss that what is a linked list, right? So basically a linked list is a linear data structure. So what do you mean by linear data structure? So linear data structure means the element are storing in a sequence manner, in a like a memory. So in this, the element are not stored at a continuous memory location, but it can take like any like reference, right? But it will be in a sequence manner. So the element in a linked list are linked using a pointer. Basically, the main point is that the elements are linked using a pointer or a reference of the address. So in simple word, we can say that a list consists of node. Basically, a linked list has a node, and the node contains two part. First, the data field, and the second, the reference field. So the reference field contained the address of the next node, and the data field contained the value of that particular node. So node is a class, and in that class, let's say that two elements are defined. First, the data field, and second, the reference field. So data field contains the value, and the reference field contains the address of the next node. So basically, the linked list is a collection of nodes, right? So let's like discuss or understand this linked list with a diagram. So here you can see in this diagram that these are node. So this is the first node A, this is B, this is C, and this is D. So here basically this is here we have the four nodes, and every node contained a data field and a next field or a reference field. So the next field contains the address of the next node, and the data field contained the value of this node. And also we have one head. So head variable contained the address of the first node, and the last node, and in the last node of the next field or data type, it contains the value null. If the value is null in the last in the node, then it defines that that node is the last node in a linked list, right? So basically, a linked list is defined as a link between a different object or different node of a class, and that class has the two property: one, the value, and the other, the address of the next node, right? So this is the diagram representation of a linked list. Now, why we can use a linked list? So basically, we know that arrays can be used to store a linear data of a similar data type, but the arrays also has some like limitations, and the limitations are like the size of the array is fixed. So we must know the upper limit of the number of element in advance. And if you know that in an array, in the starting only, we need to define the size of the array, and that size will be fixed, we cannot change it further, right? So this is one limitation of an array. And the second like limitation is that inserting a new element in an array of the element is expensive, because every element gets shifted by its index if we insert any element in the middle of an array, right? So this is the limitations of an array, which is the advantages of linked list, and that's why we can use linked list and we can go for a linked list. So now let's like discuss some like difference between an array and a linked list to understand more about this. So in array, we define the size of the array and the type of the array, right? And once we define that array and initialize that array, then further we cannot change it, and we also cannot change the type and the size of an array. So if we have defined the size of an array as 20, then further we cannot change the size of that array, right? So for increasing and decreasing of the size is not possible in an array, and I hope you understand my point, right? So but in the linked list, it automatically get increase the size as per the requirement. So what does this mean? This means that let's say that I have to add a 5 element, then we don't need to provide any size in the starting of a linked list when we're initializing. So if it needs a 5 element, then it will create a 5 node. If we have to add 100 element in a linked list, then it will only create 100 node. It means that it will take that much memory which is required, right? It is not like an array in which we have to define the size in the starting. So uh, so yeah uh, so the another point we can say that if we need like a 40 student, so we have to create the size of the array as 40. Sorry, so let's say that okay, so let's say that 100, we have defined the size of the array as 100, and now we required only a 40 element to store in that array. Then the size of the 60 element will be like vested, right? But like this is not with the linked list, because we don't define any like array size in the starting. So if we have to define 40 element, then it will create a 40 nodes for it, right? So it is very efficient in a linked list. It is going to reserve that much of space in a RAM, like whichever it is required for that. I hope you understand the idea that why we should use linked list over an array, and it totally depend on the situations and also the requirement of the project or the logic. So somewhere we can use array also, and somewhere we can use linked list also, right? So this is like totally depend on the situations or the implementations required according to the requirement. Now let's discuss some advantages over the array, and I hope this point we have already discussed. So first point is dynamic in size. So like linked list are dynamic in size. We don't need to define the size in the starting. It can grows according to the requirement. And also the ease of insertion and deletion. So in the linked list, we can easily insert and deletion, because here the shifting of the every element through the index is not done as it is done in the array, right? So now let's understand the drawbacks. So we have the advantages of the linked list. So in the same way, we have some like drawbacks also. So here, the random access is not allowed. We have to access elements sequentially starting from the first node. So we cannot do binary search with a linked list efficiently with its default implementation. So if we have a default implementation of linked list, then we cannot do any binary search. And so we have to access elements sequentially. So random access is not allowed. As in the array, we can access the element randomly by giving the value of the index. So in that way, we can access the element in an array, but this is not possible in a linked list. So this is the one drawback. And the second drawback, that it takes an extra memory. The extra memory means it has a node, as we know, and the node contains the two fields, the data field and the address field. The address field contains the address of the next node. So this takes some extra space for storing the pointer and the value. Okay. So yeah, so drawback is that it takes an extra like memory space in our RAM or in our heap memory, right? So this is the two like the drawbacks of a linked list. Now let's discuss the type of linked list. So basically there are three type of linked list: simple linked list or singly linked list. Second, the doubly linked list, and third is the circular linked list. So we are going to discuss the every type in a very deep manner. So first we will start with a simple linked list or a singly linked list. So a simple linked list is a type of linked list that is like a unidirectional. It means that it can be transversed in only one direction, and that is from head to the last node or the tail. Means in a forward direction only we can do the transverse or we can move. So in singly linked list is a unidirectional. In only one direction we can move. So each element Okay, so each element in a linked list is called a node, and the node contains the two part. First, the means the data variable which contains a value, and the second contains the next variable which contains the pointer or the address of the next node. Right. So this is about a singly linked list. So the first node so now by seeing this diagram, we can understand that this is a singly linked list, and it also contains a head. So head variable contains the address of the first node, and this every node contains a two part, the data part and the next. So next contains the address of the next, right? And in the last node, in the next variable, it contains null. So whenever we find null in a next variable, then we can say that that is the last element or a node of an linked list, right? So in this, the main point is that we can navigate only in a forward direction from head to tail, right? So this is all about a linked list. Now we are going to discuss like what are the operations we can do basically in a singly linked list. So the first operation we can do is we can search for a node in a list, right? So it means that we can retrieve a specific node either from the first or from the end or from anywhere in a list. So we can do the search operations. So now we are going to see the time complexity for retrieving a node from anywhere. Let's say that if we want to retrieve a node in between a linked list, so the time complexity will be O(n), the big O(n). So what is big O(n)? Big O(n) means the time complexity or the time consumption will increase, means increase every time if we increase the input data. Okay, so the time complexity or time consumption for doing this operation is not going to be always be same. It will like it is a proportional to your input data. If your input data is big, then the time consumption or the time taken for this operation will be also increase. So this is not constant, so that's why it is big O(n). Now the next operation we can do, we can add a node to the list. So we can add a node into three ways: in the starting, in the last, and like in between, anywhere in the list. So the time complexity of these three will be, first, if we are adding an element to the front of the list, then it will be O1. And then if we are adding to the end of the list, then it will be big On. And if we are adding to anywhere in the list in between, then it will be big On. So what is big one means? If we are adding an element in the front of the list, then the time complexity will be big O1. So big O1 means that the time complexity or the time taken for this operation will always be the same. It will not increase or decrease by the input data. If we decrease or increase the input data, then also the time complexity for taking will be the always be the same, right? So this is all about the time complexity. And uh, and how we can add an element. Let's say that I want to add an element in the starting of a simply linked list. So what I have to do basically, let's say that I want to add an element in the starting of the singly linked list. Then we know that the head has the address of the first node. And before this node, I want to add one more node. So it means that now head has to point to this new node, right? So we are going to store the address of this new node to this head. So, and also this new node will has two part, the data variable and a next variable. So so in the next variable of this new node, we will provide the value or the reference of this first node. So by this way, we will add one element in the starting. Now let's say that I want to add any new node in between the second node, means in between. So what we have to do, so as for now we know that the second node contain the address of the third node. Let's say that I want to add one more node here. So now what I will do, in the next variable of this second node, we are going to store the reference of this new node. And in the next variable of this new node, we are going to store the address or the reference of this node. So by this way, this next will now refer to this new node, and this new node will refer to this next node. By this way, we are going to insert an element in this in between, right? And this will go, means it will be unreferenced. So in this way, we will able to add one new element here. Now let's say that I want to add an element in the last. So what we have to do in the logic, in the last node, in the next variable, we know that it will be null. So we will store the reference of this node in the next variable of this last node. So in this way, it will point to the next node, and in this new node, in the next variable, we are going to store null. So in this way, it will become the last, and this will point to this new node, right? So in this way, we are going to add an element in the starting and in the last, and also in between the list. So this is the logic which we can apply in our program for adding an element. Now let's see the next operations which we can do. Means we can also delete an element. Okay, so we can remove the node either from the front and from anywhere in the list, right? So how we can do this? So let's say that I want to delete this node. So for that, and I know that the next variable of the second node contains the address of this node. So we are going to unrefer this. Okay. And then in the next variable, we are going to store the reference of this node. So in this way, we are going to unrefer this node. So now the second node will refer to this fourth node. And in this way, this node will get unrefer, and this node will get deleted or removed from the list, right? So this is the logic which we have to apply. Okay, so this is about removing a node in a list. Now we are going to see the next a doubly linked list. So basically the limitation of the singly linked list. So by like watching the limitation in a singly linked list, the doubly linked list come in picture. So what happened in the singly linked list? As we discussed, the singly linked list is a linear data structure, and it comprises of nodes chained together in a single direction. Okay, each node contains the data member, including the useful information and a pointer to the next node, right? So this is all about a singly linked list. The problem with this structure is that it's only allowed to transfer or to move in a forward direction from head to tail. So now the doubly linked list come in picture. In doubly linked list, in a node, it contains the three part. Okay, so it contains the three part. The first part is the previous variable, which has the address of the previous node, and the data variable, which has the value of this node, and the next variable, which has the address of this next node. So now in doubly, it contains the three. It also has the address of the previous node. So in this way, in doubly linked list, we can navigate forward also and in the backward also, because now the previous variable has is also there, which contains the address of the previous node, right? So it contains the three part in doubly linked list. So this is like come in picture when after seeing the limitation in a singly linked list. So in doubly linked list, we can move forward and also in a backward direction. It contains the three part, right? So the worst case complexity is like searching, insertion, and deletion is like big O-N. If we are like inserting, then it will be big O-N. Okay, and then if we are searching from the head, or like deleting a node from the starting, then here the time complexity will be O1. But if we are doing any operation in between, then it will be On. If we are doing any operation in front, then it will be O1, right? So this is the time complexity of doubly linked list. Now we are going to discuss a circular linked list. So as we know that in doubly linked list, in the last next, it contains null, right? But in circular linked list, basically it is a variation of a normal linked list. So in a circular linked list, as the name suggests, the list does not end. Instead, it's form a loop around. So the last element of a circular linked list point to the head of the linked list, right? So now the last element contains the address of the first node. So in this way, it form a circular. So a circular linked list can be implemented at a singly linked list or doubly linked list. So we can implement this circular linked list in a singly or in a doubly by assigning. So here in a direction, you can see that that in a singly linked list or in a doubly linked list, the next contains the null, right? But now the next contains the address or the reference of this first node. So in this way, it form a circular loop, right? So this is all about a circular linked list, right? So these are the three type of linked list are there. And yeah, so like basically in any type of linked list, we can do like operations, like we can add an element, and we can add an element in the starting and in the last and also anywhere in between. In the same way, we can do the second operation as deletion, means we can remove any element or delete an element from the list. So there are also three parts from where we can do. We can delete an element from the starting, we can delete an element in between, and we can delete an element from the last. And also the third operation which we can do, we can display all the values of the element or node which is present in a linked list. So these are the three operations basically are done. So what we will do in our next lecture, we are going to write a program by our custom implementation of a singly linked list in a Java language, right? So we are going to see how we can implement a singly linked list, and there I will implement this method, like to add an element, to delete an element, and also to display an element, right? So in the next lecture, we are going to see the program part, and in this lecture, we have discussed about the theory of this linked list. So thank you and have a nice day, and see you in the next lecture.